Good morning, guys. This is Miss Garner, and I'm going to be walking you through an example for the scientific notation extension project. So for this project or this activity, we have two numbers that are written in scientific notation, and we want to multiply them together. So the first thing you need to know is if they're regular numbers, so in this case, the 4.2 and the 6.1, you're just going to use the regular operation of the problem. So in this case, you're just going to multiply. So I'm going to take my two big numbers, the 4.2 and the 6.1, and I'm going to go ahead and multiply those together. So 4.2 times 6.1. And this, you're just going to, you can do it by hand if you want. I'm going to go ahead and do it on my calculator. And you get, let's see, 25.62. Okay, so that's my first thing that I'm going to do. The second step that I'm going to do is I'm going to use my exponent rule. So remember, a multiplication problem, our rule is to add. So I'm going to take my two exponents here, the 3 and the 2, and I'm going to add those together. So 3 plus 2 equals 5. And now I'm going to go ahead and rewrite it in scientific notation. So I have my big number from down here, so I get 25.62. Remember, it's always times 10, so times 10. And then I'm going to take my exponent from the exponent rule that I did, so the 5. So times 10 to the 5. So those are those two numbers multiplied together, written in scientific notation. But you will notice that it's not correct. It's not in correct scientific notation because I have two numbers to the left of my decimal. So the last step is I need to move this decimal one place to the left, because I want it to be 2.562. I only want one number to be to the left of it. So if I move it, it's then going to be in correct scientific notation. But remember, moving the decimal place, that's going to change your exponent. So you see up here, we have this little hint for you. So in this case, we're moving the decimal to the left. So we're then going to subtract from the exponent. So we moved it one time to the left. So I'm going to subtract one number from my exponent. So instead of 10 to the 5th power, I'm now going to have 10 to the 4th power. And then this is my final answer. It's in correct scientific notation, and I've adjusted the exponent based on the number of times I had to move the decimal. Same thing with division. If you look at our division problem here, your first step will be to divide your big numbers. Your second step is to subtract your exponents, because that is our exponent rule. Your moving the decimal is the same as when you do the multiplication. So if you have to move the decimal to the left, it will be subtracting. In this case, if you look at this problem more closely, we have to move this decimal one place to the right, and that is why we have to add one number to our exponent.